This year, he has dedicated 2020 to trying all different types of coffee and making more and more elaborate lattes at home. So everyone, please welcome Rafi.
Good morning, everybody. Well, thank you, Jared, for the introduction. I really appreciate that. Yeah, I've been doing a lot of lattes at home. It's actually a pretty exciting side business. I'm going to have to start inside of R. Good morning, everybody. This is going to be a talk about something that I'm really passionate about. It actually was the same topic of the first DCR meetup, is how do you take solution from R, not just it's not a statistical analysis, but a solution for clients, and what we've done around really serving it as a solution for client out in the real world. So a little bit about myself real quick. Again, I'm a lead data scientist for Deloitte. I run R for governments at Deloitte GPS. And I do a lot of work around different agencies, a little bit of commercial, really focusing on the advanced analytics part over there, again, using R in particular. And before I start, I just want to say thank you for two individuals who are building on their work on Plummer and Ducker. I think, if you have opportunity, really look at what they write about and the work that they're doing. A lot of what you're going to see over here really stem from there. So this talk is really not going to be about, I'm not going to show a whole lot of code. It's really about how I had a problem and how do we went about solutioning that using the tools that are available to all of you without needing for a huge infrastructure. It's not a Docker training. It's not an AWS training. It's the little that you know to make this thing work, and then you can go from there and Stack Overflow, etc. So again, I am going to focus on 4 aspects of a solution, how I deliver R at capacity to production to an entire state. And we're going to start with the left side of the equation of the R model itself for recommendation. We'll touch a little bit about that in the Plumber. How do you actually serve that? How we containerize that and really able to serve that as a whole. And then using microservices, essentially, how do I use AWS capabilities, which are allowing us to take this R model and really serve it at scale without the need to know a whole lot of cloud work. And finally, how do we communicate that out to the public? And again, this is a real solution. You guys can hit it right now, and I'll show you in a second how. So a little bit of a background, and this is a text-heavy slide, and I'm not trying to, I know it's a Deloitte feature, but the solution that we have built under an umbrella called GovConnect is really how state and local governments are really communicating to citizens. The solution specifically over here in Kentucky is a resource engine. And what this is provide is an access to citizens to know what services are available to them in the community. Food bank, which is very, very important right now, education, clothes, childcare, and the like. So this is a website that you can go into and really search for based on your location. And if we know something about you because of the eligibility system and what the state know about you, we can start giving you access to resources that might be benefiting to you. Specifically, the work that we have done the R work is really related to the personal intelligence, which is the items users like you, like Amazon, users like you who looked at A also looked at B, or users like you who looked at A also considered B or will benefit from C. The reason this is really important is because we know that most people don't actually know what's available to them. Not everybody is Google savvy. It's really important that we really enable people to either self-sufficiency, enable people and nudging them in the right direction, but more importantly, it's the community helping the community. everybody like you will help you get to where you need to be. And that's kind of why this kind of capability is really important. What it actually looks like is like that. When a user gets to a resource, they have some information that they can see around, for example, skills. And at the bottom, you can see frequently paired together and related services. And what you can see over here, and related services are similar. It's the same thing, just maybe in a different location. And the frequently paired, that's the complementary. That's where the recommendation come into place. And that's really where you start getting other services that you may not know about that you can actually get access to. And again, all this is live and in production. Now, the uniqueness of this situation, of this, is it's not like Netflix, it's not like Amazon. The reason that it's not is that because we don't have 1 to 5 rating, nor do we have anybody buying anything or purchasing anything or anything like that. The goal is really for individual to become aware, to actually know that this exists. That's essentially it's a success. Now, we don't actually get rating. We know if you connected to something, but we don't actually get rating because only if you come back and say, yeah, that partner, not the service, but the partner was good, then we get some feedback back. Now, it's also binary and implicit. So it is essentially it is essentially the yes or no, did I connect or not? And finally, again, we only care about relevancy. Now, let's go into the nitty-gritty of the solution. So what we have over here is, again, we have the R capability around the code, the get the data, the modeling, and we'll touch on that in a second. The delivery is feeding into Plumber. All of this is Dockerized, sitting on a Farragut infrastructure, which is a serverless serving of this Docker, and it can scale up, and that's how we can serve an entire state. And then behind API gateway, so we have security. So the system, my R code and the model and the data is actually secure and only get through the API gateway. So I will walk through each one of those items and the specific R component that matter. All in all, the solution, we also have the ability to reproduce it in other location. So I'm going to talk about recommendation system, but it can be applied to any model that use API and the like. So deep dive into the recommendation first. The first aspect that I want you to think about is that we essentially segmenting the population, think clustering. And by the way, segment is not all pregnant women. It's essentially people who will behave similarly. And it's essentially, I'm first boiling it down from the entire infrastructure. We have the metrics that we created. And again, you can see it's a function of the information that we get. We created a metrics. And then using this wonderful library Recommender Lab, I'm creating an item-based collaborative filtering. So I'm encouraging all of you to go and Google what item-based collaborative filtering, but think about this as a metrics where I have the items or the individuals that actually are selecting that and the items that, or the resources, food bank and the like, that they actually selected. As you can imagine, this is a really, really, really sparse metrics. So we have to handle that. But the recommender functionality will create that real metrics that then create this outcome, which is essentially the base for the model. Now, the second part, how do I actually make this? Okay, you build a model. How do I actually do something with that? So the second part over here is that I create the Plumber functionality. So in 3 seconds or less, I'm creating, and you can see at the top right over here, I'm creating the post functionality of Plumber. So that means that it's not through the URL. I can actually serve a body, and you can see in a second why I need to serve a body. But this is information such as the user ID, where they are, and what they're looking at. And what I'm passing to this RE base model. So this is my example for the purpose of this demo. This is the base model that I'm serving, and you can see on the right over here that I am getting a function. I'm getting the user, the variable that I need. I'm using my function get ranking, distance matter, for example, how far you are from the resource that I'm trying to recommend, and essentially, the outcome of this function is a response out, which is essentially a list. This is important because, again, in the API, I'm serving a JSON file, and we'll get there in a second, but this is important. I'm serving a list. Now, and the next piece is actually the critical, and this is if you remember anything from this talk, is the next piece. I'm serving the model. I'm creating the plumber router. That's through the new PR functionality. A few months ago, a new plumber library was released. It's wonderful. I encourage all of you to take a look. But what's important over here is now I am using the PR run to start a server. I'm using a host 0.0.0.0 on port 5001. Now, this is really critical. How do I serve this? The reason a port is essentially that's the port where we're listening on. But why do I need the host .0.0.0.0.0? The key over here, and this is really key how to serve this in production, is that by default, Docker has its own namespace. The namespace is essentially its own infrastructure IP and the like. If I want to connect the Docker to a different environment, I need essentially to forward the port from the 5001, the port that I'm actually opening, and the IP that the Docker provide, and you can see on the right the bridge. I need to essentially listen to all of them. So to achieve this, I need to listen on an external IP inside the container, and 0.0.0.0 is all IPv4. So it's listen to everything. That will allow me to have the connection from the Docker to the external environment. Now, once you do that, now you can create the Docker. And this is where it's a very, again, you can, this will be posted. This is the classic Docker for R. I'm using the base Rocker environment. We updating the Linux. I'm creating a copy. That's copy everything from my directory, all the code, all the data, all the functionality that I need in order to serve that. I'm running the script setup, and that's all the install library X, install library Y. And then I open the 5001, which we discussed a second ago. And then the entry point is the container start. It served this SME base SR base S1. That's my, I'm not really good at naming. I'm the first one to admit that. And that's where it's going to start. So it's going to start this server that essentially starts the plumber on 5001, which then show the RE base functionality that we saw over here, RE base model. Now comes the fun part, is the AWS infrastructure. I took this Docker, Dockerized that, I put it on ECR, that's the services from Amazon to where Docker can live. At a very high level now, and again, this is not a training on AWS, but I'm going to tell you essentially what we found was the right way to set this up. And a lot of it, you can use the wizard of AWS. You use Fargate for clustering, and we'll touch on this in a second, behind application load balancer, behind API gateway, and there's some CloudWatch for logs. So Fargate gives me essentially the services that would scale up using the application load balancer. The method is how API gateway check, is it a post, is it a get, is it part of the URL, is it a package? And the API gateway is essentially how AWS managed the connection to the external services. That is where the API will actually live. So in the next 2 minutes, I'm really going to talk about these components. And while you can read and learn about how to do this and how actually to deploy that, where is the plumber and the R comes into place. So the first thing that you need to do is to create that cluster. So if you go to ECR and you create cluster, the first thing that you need to create is the task. And what's important in the task is that you need to link to the container. You need to say which container you're actually using. And very important over here is that when you open the container, when you link to the container, it will ask you, what port you're listening to. So the classic port 80 is, open to, or port 20. Those are the classic one that kind of internal communication. No, use the 5001 that we open in the plumber. It's because that's how plumber is essentially sending out from the Docker container out to the environment, the recommendation. The second part over here is that now you need to go and create an application load balancer. You go through the wizard, you can see configure load balancer, configure security, and the like. But really important, again, when you when you get to the routing, that's the target, what it's essentially targeting. Again, you can see IP port 5001. Again, you will see that there's a path over here from the plumber that opened my function on 5001 through the task, through the load balancer. The next step is looking at the service. So you go back to the clustering, and now you set up a service. And you select the service. It will ask you what do you want to do, regular or Farragut. Choose Farragut. The reason Farragut, I should have mentioned that, is Farragut is essentially their serverless. They will manage for you how much you grow in compute power. So the more you hit it, the more Docker container will be spun out. I should mention that this is actually really, really, really fast. With the new rocker. So this is actually, thank you. So you create the service, and again, you select your virtual private cloud, etc. But again, what's really, really important is that when you create the service, when you get to the security group, essentially what IPs can go in and out, you look at your port for the application load balancer. You're using the application load balancer is a group ID, and the port range again is 5001. Finally, we get to the application, to the API gateway, and this is a nifty trick that I'm actually learned, and I think this will be very interesting to everybody, is that when you set this up, instead of a post or GET, you set it up as a proxy, and then in the endpoint URL, you use the stage variable, and I get it real BT6. That's my stage. Not going into exactly what stage is. It's essentially where you have all your variables that API gateway needs. The important thing is the curly bracket proxy curly bracket. This is important because that would say that when I hit it with a function name, it will go to the Docker, all the way back to the Docker, and it will rebuild the URL saying, I need this location, etc., that name of a function. So I can hit that Docker with any function that my R infrastructure actually serving, any function, RE based in this case, but it can be other ones. And this is essentially where this is the key over here, is that means that I can control all my function through the R, and API will just pass it all through, but only through the API. Essentially, it looks like that, and you can see it coming from my client all the way to my proxy, hit the proxy, and go back. I will finish this by actually showing you, this is a SOAP UI. I'll show you how that's actually work in practice. You can see over here, I set up a post. I set up over here the API. Yes, I know it's East 1. I know there was issues over there, but that's why you need multi-zone. But this is the name. And you can see that I didn't name the name of the function. I'm naming it in the resource. And my proxy will take this RE-based model and rebuild it and hit, and it will spawn the Docker and we'll get a response back. And here's my post, and you can see I'm providing the latitude and the user ID. So let's run this real quick. And what you can see is that we're taking that, this post request, and I'm hitting that. And here's my recommendation. Just like that, I got a recommendation from my Docker that is based on R, that is based on Asperse metrics, that is essentially was built elsewhere. And now I can serve it to thousands of people all at once, or go down if I don't have to serve to anybody, and at minimal cost. This is really what we called in analytics as an API. Essentially, it doesn't have to be recommendation engine. Any sort of prediction that you want, and you want to serve it at scale, you can use this type of ID of using Docker, Plumber, application load balancer, a Farragut, and API gateway.
All right, that was a fire hose. It's really like to be a data scientist today, you need to be a full stack data scientist and understand the elastic load balancing and APIs. There's a lot to be doing. It's no longer just knowing how to fit a good model.